And I am live. That is pretty cool. Today is 13th of October 2025, Monday. And with that, let's begin building our game in Rust, which is a little like clickbait. You cannot expect to see like Unreal Engine, Cyberpunk being built here, even though Cyberpunk was not built in Unreal Engine. Yeah, you don't expect something like that. But yeah, not normal things are here. We will use, of course, the book. It is just called the book. Like even here, read the book. And here, chapter number 2, we have programming, a guessing game, and that is nice. We will do a guessing game. But before we do this, I read the first chapter, this one, getting started, and there were a few things which I would like to go through here right now. And the few things were not this. The few things were that there is a thing called Rust Up, and this program is used for updating and getting the latest version of the Rust compiler. And there is Rust C, the Rust compiler, and then there is Cargo, and Cargo is a tool which has Rust C also within itself, but also Cargo helps building your package, your whole like project, right? And Cargo also helps you to download and use dependencies in your project. So yeah, Cargo is for that, and you can individually use Rust compiler to compile each and every single file in your Rust. And but yeah, that could be tedious. If you want to use external dependencies in your project, you would need Cargo, and that is what most of the uh, crustaceans use. I think that is the correct spelling. Crustacean, crustacean. Yeah, crustacean. Yeah, that is what Cargo is what most of the crustaceans use. And there were some other things. Yeah, let's just go through with this. Let me go to a folder, cd rust, rm, rf, everything in this folder. Yep, ls, lsa. Why do I still have a git thing? Rm, rf dot git and dot git everything. Ls, yes, now git is gone. Okay, and we can use cargo new to build a new project. And let's say cargo new, yeah, just cargo new. And okay, we also have to give a path, cargo new test. Okay, we still do not have anything here. Creating binary application test package. The name test cannot be used as a package name. It conflicts with the Rust's built-in test library. Okay, so we have to use something else. Uh, cargo new test personal. Now that does work. And we do have a directory with the same name. And here we have two things. First, we have cargo.toml, and this has information about the package that you are creating, about our personal project. And okay, and this format .toml format is the one that Rust uses, or Cargo uses, not Rust. Cargo uses to express details about the project, and toml means Tom's obvious minimal language. Toml. Yeah, that is just what Cargo uses. And if we see, open this thing, here we have the name of the package, the version of the package, and the edition. We can change whatever we want, and whenever we want to add some dependencies, they go here in the dependencies section. And this is sort of like how we work with HTML, how HTML packages are like handled and stuff. Hello, good afternoon. How is everything going? And today we are going to build a game, a little guessing game in Rust. This is going to be fun. This is literally going to be fun. But before actually going through this article, or you could say it also manages packages, and also it helps build your project from scratch. And when we initialize a new repository in Cargo, a new package, we get two things. First, cargo.toml, which has details about the package, and this thing, source directory cd src. Here we have a by default main.rs file and main.rs file, and it just has this thing. Yeah, just a single print hello world line. And if we want to build this thing, we just do cargo build. It is built. And the final thing, now we have two new files, cargo.log and target. Target has the build, and cargo.log contains the exact versions of all the dependencies which we used to make this target file. And yeah, we normally do not have to do any manual changes into cargo.log file. Like, nope, that is not up to us. And in the target directory, what do we have? We have cd target less. We have debug, because this is not there are two kinds of builds you can do in Rust. One is like normal while you are writing the thing, debug build, and then there is a release build. When we Yeah, so there are two kinds of builds in Cargo which we can use. The debug build is for the time when we are actually developing the project, and release is when we are done writing everything and we want to build a binary which we want to ship as the final release product. Then we use release, and the binary which we get when we are building for the release is much faster, and therefore the compile time for this is very high. That's the, like, yep, compile time for the release build is very high, so we do not usually do this while we are writing the code. Therefore, while we are writing the code, we have this faster, smaller build called debug, and that is what we use. So if we cd into debug, we have personal test dot personal test hello world. And if we go to the main root of the project, and if we do cargo build release, now if we go to target, we will also have the release version. And if we do dot slash test personal, it is the same program but just a little bit faster, but we do not see the fastness because the program is not even big. Hello. Yeah, it is equivalent to JSON file. Yep, same. We have debug. Yep, we have debug. And was, that is what in German. Yeah, so Rust has two builds. One is debug and one is called release. Debug is the build which we use while we are writing the code, and release is the one which we use when we want to ship our final binary. And the debug build is faster to compile, and release build is slower because this is the binary runs very fast, and in this the binary which you get is not very fast. And yeah, there are just a lot of things going on when we are building the release build. So we do not do this while we are building the project. And also there is one more thing. If we do cargo check, this thing does not build our project. This just tells us if there are any mistakes in our project. So yeah, this is just while you are writing the code, you do not want to actually build the whole project. You just want to check if the additions that you have made to your project, are they causing any compilation errors. If you just want to check that without building, because building is slower, even when you are building for the debug build, It is also like slow for big projects. And sometimes you might just want to check if there are any compilation errors. You can check that with this cargo check. And with that RMRF, let's do this programming a guessing game. That is going to be fun. We will build a game. Okay, let's jump into Rust by working through a hands-on project together. Okay, this chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You will learn about let, match, methods, associated functions, external crates. Okay, crates in like in normal JavaScript, Node.js, external things are called libraries, and also in C or C++, external things, external packages are called libraries, and the same things in Rust are called crates. They just have a different lingo. Crates, this is just Rust lore. And more, we will read about more. In the following chapters, you will explore these ideas in more details. In this chapter, you will just practice the fundamentals. That is nice. We will implement a classic beginner programming problem, a guessing game. Here is how it works. The program will generate a random integer between 1 and 100. It will be then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Okay, this game is close enough to, I would say, amazing games like Cyberpunk. This is just, I would say, the difference is 1920, just a little bit, few percentage here and there. Yeah, the concept is literally the same. Yeah, close enough, close enough. After this, we would be like very close to making actual real games, which people would play. So yeah, this is pretty cool. Setting up a new project. To set up a new project, go to the projects directory that you created in chapter 1 and create a new project using cargo like so. Okay, we can create a new project, and then the first command, cargo new, takes the name of the project guessing game as the first argument. The second command changes to the new projects directory. Yes, cd. Look at the generated cargo.toml file. It would have something like this. That is nice. As you saw in chapter 1, cargo new generates a hello world program for you. Check out the source main.rs, which will have this. Okay, let's compile this hello world program and run it in the same step using the cargo run command. Yes, if you want to build and then also run automatically, we can use cargo run, which will under the hood first of all build and then run the executable that we got in one step, cargo run. And we have done all of these things just now. We did all of these things. So okay, the run command comes in handy when you need to rapidly iterate on a project, as you will do in this game, quickly testing each iteration before moving on to the next one. Reopen the source main.rs file. You will be writing all the code in this file. Okay, let's set up the game. Cargo new guessing game. Okay, we have the guessing game now, and cd src, and let's also do, just in case, cargo run, and we do get hello world, and let's enter main.rs. Here we will be writing everything. That is nice. Why you say that? Shh, I thought of watching this stream, but now we go. Okay, it is close enough, close enough to Cyberpunk. The first, and yes, there are games built in Rust. Games in Rust. There was a game like Minecraft. Games in Rust can refer to many games. Impressive games I have seen in Rust. Valorant, yes, look at this. This is built in Rust, and that is nice. Minecraft like game. Shit, this would be really cool to actually make this. Is this on build your own X? If this is on build your own X, then we will make this next year. Nah, shit. That is nice. That is funny. Game. Yes. Games with Go. Okay, build your own game. Handmade hero. How to program NES. Learn Dangerous Dave. Shit, I think I've heard this name. Dangerous Dave. Shit. That is a game. Dangerous Dave. Shit, crazy. Tetris, we can build Tetris in C, literally C, not even C++, in C. Coding a road, Sudoku, okay. Tetris in C++, okay. Space Invaders, C Sharp. Games with Go, 2D, 3D game, Java. No, it is Java. 8-ball pool. That is crazy. In just 59 minutes, you can do this. Part one, part one. Okay, this is part one. This is part one, and this is the final product. Shit. Index.html. Okay. Ruby Snake Adventures in Rust, a basic 2D game, and roguelike tutorial. And Hyuan, a basic 2D game. 2018, bro did this in 2018. Shit, we have a pixel rotating. Shit, we have more pixels. Bro, this is crazy. This looks pretty cool. We have to navigate without touching these, it seems. Shit, that looks cool. That is, yeah, really a basic game. Okay, anyways, getting back to our guessing game. Please make a NFS-like game. What is NFS? It is been about 20 years since a good racing game came out. It's like to make a better game. It's time to make a better game. Wait, don't we have like F1 racing games? You can buy a handle and do sim racing. That would be nice. Some Tim Sweeney level shit. NFS shit. Need for Speed. I've only played Road Rash as a child. This looks cool. Oh, you can play F1. I don't know if F1 game is pretty cool or not. Need for Speed, Most Wanted. You didn't play it? Nope. I have only played Road Rash and Taken 3. That is all. And Vice City. Of course, yes, Vice City. And yes, we have everything. Now, processing a guess. How do we process? That is too much code. The first part of the guessing game program will ask for user input. Process that input and check that and we also have to generate a random number and check if it is correct or not. Okay. The first part of the guessing game program will ask for user input, process that input and check that the input is in the expected form. Shit, yes, that is also correct. Check if the input is in the expected form. Shit, doing competitive programming, I forgot that we also have to do this. We also have to check if the input is in the expected form or not. Nah, that is my childhood. Do not shit on my childhood. Road Rash, one of the best games. You can like go off the track and drive on the grass. Okay, I haven't played NFS, but okay. To start, we will allow the player to input a guess, enter the code in listing 2.1 into this. Okay, what do we have here? Println, guess the number. Then println, print input your guess and let mutable number guess equals a string new. So we initialize a new string and IO input output standard in. Okay, in the standard in function, we are calling the read line and we are giving address of guess and expect failed to read line if some exception error happens, then print failed to read line and then your guess. Okay. Okay, let's do this. Print ln, ln degenerate, game starts, print ln, enter your guess, and then we say let mutable guess equal shit, lsp is off, lsp start. Shit, is it not working? Okay, it is working. String new, it is unused, that is fine. And after this IO, shit, IO standard in, yeah, dot dot, what do we do? Read line and expect give address mutable guess and then expect unable to read line. Okay, there is something wrong. Rust C failed to resolve. Okay, let's turn LSP stop. Standard in read underscore line, not just that. Camel case. Okay. Shit, this is not camel case. This is snake case. Yeah, I guess this is snake case. And then print your guess. Hmm. Okay, and we have to do this. Use stdio. Wait, I think we can also do this. This would still work. Mute guess and print line. Your guess is guess. Let's see. Cargo run. Okay, it does run. Enter your guess. My guess is hello there. Hello there. Your guess is hello there. That is nice. Main.rs. And if we do not want to use this at the top, we have to say use stdio, and this should still work. Cargo run, and it does not because help should, it literally tells you what you have to do. Main.rs cargo run, not to end, cargo run, and high, your guess is high. Cool, that is working. That is pretty cool. Lol, yo. Yeah, I have also played Road Rash, that like our first racing game memory. Yes, system specs matter, bro. Should we have to system specs matter for NFS? They do matter. This code contains a lot of information, so let's get over it line by line. To obtain user input and then print the result as output, we need to bring the IO input output library into scope. The IO library comes from the standard library known as std, just like C++. std IO should std C in C out. I'm forgetting C++. By default, Rust has a set of items defined in the standard library that it brings into the scope. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. This set is called prelude. Okay, like in C or C++, we have include files. Here we have use things, use this, and this is called prelude. Okay, and you can see everything in the standard library documentation if you were to click on this. Okay, if a type you want to use isn't in the prelude, you have to bring that type into the scope. Okay, shit. Okay. The things that are in the scope by default, those things are called prelude. For example, here we are using a string without using anything else. Like we don't have to do std string to get it. A string is just there. So string is a part of the prelude. So we do not have to explicitly use std string, but IO is not a part of the string of the prelude. That is why we have to do this. Explicitly add input output to our program. Okay, prelude and then explicit addition of the things that are not a part of the prelude. If a type you want to use isn't in the prelude, you have to bring that type. Type or namespaces. I think namespaces would also be a good term for this. In the IO namespace, we have a function, and this function returns a type, and on that type, we are calling this function. Okay, this method with a use statement using the stdio library provides you with a number of useful features, including the ability to accept user input. As you saw in chapter 1, the main function is the entry point into the program. FN. The FN syntax indicates a new function. The parentheses this indicate there are no parameters, and the curly braces starts the body of the function. As you saw, also learned in chapter 1, println is a macro that prints a string to the screen. This thing is a macro which prints some string to the screen. That is nice, but also what if we were not to use this exclamation mark at the end? LSP start rest analyzer, and there is error found macro println, not a function. Expected function found macro println. So println is a macro. Okay. I guess we will get to know why this thing is a macro and not a function over time. This code is printing a prompt stating what the game is and requesting input from the user. Yep. Storing values with variables. Next, we will create a variable to store the user input in like this. Let mutable guess equal to a new string. Now the program is getting interesting. There is a lot going on in this little line. We use the let statement to create the variables. Here is another example. Let apples equal to 5. Okay, this line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default. By default, variables are constant, which is crazy. And if you want the variables to actually vary and not be constants, you have to explicitly say this thing is mutable. That is kind of crazy. That is also like, yeah, that is crazy. Uh, yeah, this is like opposite to any other language. Immutable by default, meaning once we give the variable a value, the value won't change. We will be discussing this concept in detail later in chapter 3. To make a variable mutable, we add the mute word before it. This is immutable, this is mutable, and this are comments, it seems. Yes. Note the dash dash syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We will discuss more in chapter 3. Okay. Returning to the guessing game program, you know that let mute guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something to the variable now. Okay, now, literally right now. On the right of the equal equation is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable, that is a growable UTF encoded bit of text. That is kind of crazy. Okay, a lot of things are going on here. We use the let and mutable keyword to say that bananas, or like guess, is a variable. We are defining it, and then we are using the equal to mark to say whatever is here, bind this thing to what is returned by this, and this thing is creating an instance of a variable or object. This thing is creating a new instance of a string, where this is very triggering that the S is capital. This, like, why is it capital? But okay, S is capital. Okay, and this string new creates a new instance of a string type. Okay, and string is a string type provided by the standard library that is growable. String is a string type provided by the standard library that is a growable UTF-8 encoded bit of text. So what is a string? String is a growable UTF-8 bit text. So we can, like, not like a normal string, like we can extend this or we can reduce the size of this string, and this is UTF-8 encoded. The double colon syntax in the new line indicates the new is an associated function of the string type. Yes, like we saw yesterday, types can act as namespaces and therefore have internal functions associated with them, associated functions. So string is also acting as a namespace, and it has a function called new. An associated function is a function that is implemented on a type. This is like a method associated with a class, yeah, something like that. In this case, string is the type which has a associated function called new. Okay, this new function creates a new empty string. Okay, you will find a new function on many types because it is a common name for a function that makes a new value of some kind. Okay, so what we have seen, types can have associated functions, and here we wanted a value of type string, so we called the new associated function with the type string to get a value of a string which we are binding to this mutable variable called guess. Okay, okay, that much makes sense. In full, the let mute guess equals a new string. Here we are saying guess is a mutable variable, and bind it which we are indicating by our equal to sign, mark, symbol, character. And here on the type string we are calling a associated function of the type string called new, which returns a new object or new instance of a string, and this is end of line. Ah, yep, and that instance is being binded to guess. That is nice. This makes sense. This makes sense. And the fact that types are associated, or types are also namespaces, makes makes this thing a lot more clear that we have associated functions with types. Okay. This line has created a mutable variable that is currently bound to a new empty instance of a string. Phew. Okay. And that makes sense. Okay. Receiving user input. How do these new things work? Recall that we called the input output functionality from the standard library with use std colon IO on the first line of the program. And now we will call the standard in function from IO module. Okay, standard in is a function, IO is a module, and std is a library. See, there is a hierarchy. Std is a library which has a module. Module is just a file inside a library, and in a file we have multiple functions, and standard in is one of the functions. Cool. Which will allow us to handle user input. Okay. Okay, the hierarchy makes sense. We could have here done std, this thing, and this thing is redundant. Okay. So here std is the library. In this library, we have a module called IO, and in that module, we have a function stdin. So that is pretty cool. A library, which is a bunch of modules, and then we have modules, which is a file. Module is a file, and a file has functions. Yeah, the last layer is just a functions. Library has modules which have functions. Okay, cool, cool. And yes, when we want to call something inside a layer which is higher in the hierarchy, if we want to get to a module which is inside a library, we use double colon like this. Okay, and we could also have called some other module like CMP min-max 5 comma 10, something like this. Let x equals this thing. And yeah, this error that we are getting, it is just saying we are not actually using this variable anyway. So what is the point of this? Which we can stop if we do use underscore before the name of the variable like this. Now it is not giving us any error. That is just one thing we can do. So here also std is a library which has a module named cmp, and in that module we have a function named min. That is nice. Okay, and then if we hadn't imported the IO module, yes, also we could, like, if we do not want to use this thing every time, we can say at the top, use std IO, so that this module is now imported into the file. And okay, so now I have a doubt. Since this module has been imported into the file, like, do we have access to all the functions in this module? And if we do have access to all the functions in this module, why do we have to add this? Like, that makes sense. Okay, yes. So does the code with that is in this module, this whole file, is it like completely imported into the current function? If it is, then why do we have to use, why do we have to explicitly say that we are using this function from this module? And yes, I should not be using mouse in Vim. If we hadn't imported the IO module with use stdio at the beginning of the program, we could still use the function by writing this function call as, yes, by explicitly saying from this library, get from the standard library, get the IO module, and from that call the standard in function. The standard in function returns an instance of standard in. Shit, okay, okay, shit. This is okay, subtle, which is a type that represents a handle to the standard input for your terminal. Okay, here this thing has a small s and this thing has a capital S, and they are saying this thing is a function and this thing is a type, right? This thing is a function and this thing is a type. Okay, okay, and okay, shit, okay. This thing is a function and this thing is a type. When we call this function, we get this type, and this is a function which is inside this module, and this type should also have associated functions with itself, since this is acting as a namespace. And we saw above, for the string type we have the new function. Do we also have the new function for standard in? If we do, if we actually do have it, then okay, let's see. We change this to capital S and do new. Okay, this does not have a new type. Okay, rest C, no function associated with the type new. Okay, this type does not have a new function, sadly. So the only way to get a standard input type with a capital S, we have to call this function. That is what it seems like. E or std in is a struct. A handle. This, like in like this documentation is amazing. We can see everything right here. That shit, this is big. This is amazing. We have everything right here. Okay, and they are also saying to get a instance of the standard input, we must use the stdin function. Okay, and then to read a line, we read a line like this, and question mark, that must be some syntax. Std in. Okay, okay, and also we will get into why, what this thing exactly does. Next, okay, I think this much is clear. This much is clear. We are calling this function, no mouse in win. We are calling this function to get a type called um, std in, which is inside the IO module. So this thing is returning a type, and on that type we are calling this function. Okay, that makes sense. Makes sense. And the next line, the read line and mutable guess calls the readline method on the standard input handle to get input from user. Okay, method readline is a method called on standard input handle to get input from user. We are also passing and mutable guess as the argument to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into the standard input and append that into a string. Append. So since our string is empty, we get the input. Input is the only thing we have in our string without overwriting its content. So if, can we like give something in here? Okay, no, we cannot. Do we have like guess plus equals I? Okay, we do have this. We do have this. So whatever we input should come after this high. Rest on carbo run. Okay. My input, my input comes after high. That is nice. Okay. Tool, that is making sense. this is also making sense, is to take whatever the user types into standard input and append that into a string without overwriting its content. So we therefore pass that string as an argument. The string argument needs to be mutable so that the method can change the string's content. That is nice. Okay, okay, okay. That makes sense. It has to be mutable and appends the text at the end of the string. The and indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature and one of Rust's major advantages in how safe and easy it is to use references. You don't need to know a lot of those in details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence you need to write a mutable reference rather than this to make it mutable. Chapter 4 will explain references more thoroughly. Okay. Okay, that is clear. That is clear. Makes sense. So in here, in the IO module, we are calling the standard in function, which returns a type called IO standard in, where S is capital, and read line is a method which we are calling on that return type. But we could also have done let std or let, yeah, st equals IO std in. Just analyzer. Let's see. Start Rust analyzer. And here, if you were to do st dot readline, this also works. Okay, that is cool. And we are reading our, like, whatever it is, the user enters into this string, and this function readline or this method readline appends whatever the user inputs at the end of this string, and we are passing this string as a reference, mutable. Okay, as a reference which is mutable, and a mutable reference to a guess which is a string. Okay, okay, I think that makes some sense at some like peripheral level. Handling potential failure with Rust. Okay, potential failure. We handle potential failure, but before that, let's see what this thing does when you use std uh, use stdio in Rust. Does the whole, okay, that might be a bit too small. Does the whole, when we use stdio at the top of a Rust file, does the whole IO module from std library gets copied into our program? Okay. And it touches the core of concept of how compiled languages in general handle modules, imports, and linking. Let's dismantle it carefully. You are not copying the entire module into your program. Instead, you are just bringing the symbol IO into your current namespace so you can refer to it without its full path. Okay, we are getting access to the IO symbol. Like, I might be using things from IO, so let me tell the compiler where to find them. No code from IO is literally inserted or duplicated into your binary at this point. Rust's compilation has three main stages relevant here: namespace, resolution. When you use this, the compiler records that any mention of IO refers to stdio module. This is purely compile time concept. Okay, this makes sense. When we use stdio, it just means that whenever we use the word IO after using this, that IO would refer to stdio. Okay. Monomorphization, okay, and code generation. When you actually use something from IO, say like this, the compiler looks at what function, instructs, or trails you have referenced. Only those parts that are actually used get compiled into your binary. Linking. The Rust standard library std is a precompiled and linked is precompiled and linked into your final binary. The linker includes only the object code. For symbols, you actually reference object code for the symbols that you actually reference and not their source code. Anything unused is discarded, a process known as dead code elimination or tree shaking. Tree, tree shaking looks cool, sounds cool. Okay, that is good enough. That is good enough. We can move forward with that information. It, yep. Handling potential failure with Rust. Okay, this is all we have written till now, and the symbol just looks amazing. The Rust mascot, this looks pretty cool. Handling potential failure. This line, expect unable to read line. Okay, if we were to like actually mess up cargo run, wait, how can we even mess up? Whatever I type will get printed. Your guess is this thing. Yeah, so wait, maybe if I do not type anything. Okay, if I do not type anything, nothing goes into the string. Okay. Uh-huh. We are still working on this line of code. We are now discussing a third line of text, but note that it is still part of the single logical line of code. The next part is this method, this thing. Expect this thing. We could have written this code as a single line, and end of line is only marked by a semicolon. So if you are not using a semicolon, that just means our current line is still going on. And also that we have to update lazy packages, update and then sync everything. Okay, so we could have, wait, we could have written this like this. This also works. Okay. And there is also like a Rust formatter, Rust FMT, which we could use to make our code look a little more standardized. Yes, as mentioned earlier, read line puts whatever. Okay, however, one long line is difficult to read, so it is best to divide it. It is often wise to introduce a new line and other white spaces to help break up long lines when you call a method with the method name syntax. Now let's discuss what this line does. Okay, as mentioned earlier, read line puts whatever the user enters into the string we pass to it. Okay, but it also returns a result value. Result is an enumeration. Okay, it is a enum, often called enum, which is a type that can be of multiple possible states, which could be of multiple. We call each possible state a variant. Okay. Okay, chapter 6 will cover enums in more detail. For the purposes of these result types is to encode error handling information. Okay, result types. Result is a standard thing, I would suppose. Result time. Okay, here we are saying st is a function. St is not a function, st is a type. And we can like literally explicitly say that st is of type Let's also start the LSP, Rust Analyzer. Okay, Rust Analyzer is working now. Yes, we are here saying that SP is of type IO std capital stdin. No error. That is nice. So st is of type sio stdin, and on that type we are calling a method called readline, and to that method we are passing in a mutable reference to a string called guess, and this method readline returns another type called result type, and that result type is an enum. Okay, it is an enum, and yeah, okay, it is an enum, and it is a type which is used to encode error handling information. Okay, and this seems to be a general type which is written by a lot of methods to handle how errors are going to be handled, I guess. Okay, that makes quite a bit of sense. So result is a general concept. Results variations are okay and error. Okay, and variations are like different states that a enum could have. Okay, makes sense. And enum is a like general concept in other languages also. We have enums in a lot of languages. Results variants are okay or error. This enum has two values, okay or error. The okay variant indicates the operation was successful and it contains the successfully generated value. Okay, the error variant means the operation failed and it contains information about how and why the operation failed. Okay, okay, this enum can have two different variants. No, no, no. I don't know what ownership and borrowing and all that is in Rust. This is like my second time reading Rust. Yesterday was the first time. Values of the result type. Yeah, okay. There can be two variations of the result type. Result is a general type, it seems, and it can have two variations, okay and error. Okay variation indicates that the process was successful and it contains the usefully generated value. Okay, so wait, okay, okay, let's go with this. The error variant means the operation failed and it contains information about how and why the operation failed. Okay, let's read this and then speculate. And I think these two things, okay and err, have internal methods to them. So this is crazy. We have enum. If this is like actually true that these two things also have methods within themselves, it would mean we have a enum, first of all, of type result. And inside that enum, we have two variations, okay and err. And these two variations in themselves have methods, because I'm saying that these things have methods because this thing is returning a result type which we can actually bind to something. result, let's say, result equals to this thing and not just this. And then we can do result dot um, expect and unable to read line. Okay, that is Very nice. Okay, so here we are calling this function which returns a type called stdin, and then we are calling this function which is returning a type called result. And where is result like defined? Just like that. Okay, okay, that is not good. What is the type of this thing? This type is result u size error. Let's write this explicitly. Okay, okay. I don't get this syntax. This must be like template syntax we have in C++, something like this. And when we get this result, which is a enum, shit, this is a enum. This is a enum. So I guess this might be what the values are in this enum, but they are also saying that result is like a general enum. So this is not variable in the sense that this can have multiple variations in it. String is quite hard in Rust. Shit. Yeah. I mean, you literally have to say mutable, and the just this thing that everything by default is a constant. So if you have let x equals 10, right? If you have this and then you do x plus equals 5, error, error, because x by default is a constant. So you have to explicitly say x is not a constant, x is a mutable, and this yellow error you are getting, it is because uh, Rust is saying we are not using this. Okay, now, but if we add a semicolon at the start of a variable name, Rust will not give us that error. So everything by default is a constant. We have to explicitly see this. Shit, cannot cannot assign twice to immutable variable. Cannot assign twice. Shit. By default, everything is immutable. That is just crazy thing. So I guess that is why people don't do competitive programming, because you do not want to say let mute x equals to something and then take input. That would be just too much work. That is okay. Adding mute is not a big deal, but string is more complex. Okay, that is okay. Yeah, I guess people, that is why people don't do this. I guess, but you could get used to this thing after some time. Okay, and we will see how strings are very, very complex. C is hard? No, C is easy. Okay, send the snippet. C is not hard. C is easy. Yes, of course. C is easy. C is not hard. C is like literally assembly, and yeah, the abstraction is not too much. However, okay, where were we? Handling potential failures, potential failures with Rust. Okay, and yeah, okay, we were here that ST is a type. ST is getting a type called IO stdin, and on this type ST, we are calling this method readLine, which is taking guess as a mutable variable, mutable reference, and it is returning a type called result, which is like a general type, and result we are naming, we are storing that returned type into this variable called result, which we can name anything, RSP, let's say. And on this variable, we are calling a method called expect, and we are passing in this, which we will read about what it means. Variations of result type. There are only two. There are two variations of result types, okay and error. The okay variation indicates that the operation was successful, and error says that the operation was a failure and contains information about how and why the operation failed. Mhm. Values of the result type, like values of any type, have methods defined on them. an instance of result has an expect method that you can call if the instance of result is an error value. Okay, this is an enum which has things. Yeah, it is easy syntax wise. Yeah, syntax wise it is easy. C++, C, it does not have like these crazy things, double colons, like that is crazy. And yes, okay, values of result type, like values of any type. Okay, shit. Okay, values of result type, like values of any type, have methods defined on them. Okay, result type has a value. Result type is literally a type. It has methods defined on them, and an instance of result has an expect method that you can call if this instance of result is an error. Expect will cause the program to crash and display the message that you passed as an argument to expect. Okay, if the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If the instance of result is an OK value, expect will take the written value of that OK is holding and return just the value that you wait. If the result type is OK, if this instance of result is an OK value, expect will take the return value that OK is holding and return just the value that value to you so you can use it. Okay, in this case that value is the number of bytes in the user input. Okay, okay, if we say let bytes equal to this thing, we will get the number of bytes. Println number of bytes is bytes. Let's see if they are telling the truth. Cargo run, and let's say hi, should be 2 bytes, 3 bytes because of new line. Shit, is this also appending new line there? Maybe, could be, I don't know. Rest is strict. You have to be sure what you are writing is safe. Yes, you have to like literally know what you are doing. They also have double colon thing, but we have yeah, we have using namespaces. Is there no namespace equivalent in Rust? Yes, there are literally namespaces in Rust. This thing stdio, you can think of it as a namespace, and this type, yeah, types are also namespaces. So this thing, this string is a type, and this is also acting as a namespace, and in that string namespace we are calling this function new, which is returning an instance of the string which we are storing here, and we are telling it that it is mutable. So yeah, there are namespaces, and yeah, this thing is just saying whenever I use IO, I am referring to the stdio thing. So I can use just IO here like this without saying I'm using IO from the standard library. Yeah. Rest seems cool. I think you have to know what you're doing to get things right in Rust, and that is pretty cool. That is pretty cool. You have to be like very specific and know what you're doing. You cannot just vibe code. Shit, can you vibe code in Rust? That would be crazy. Okay. This returns the number of bytes. Okay. Now in the result type, we have a function called expect, or not, associated function called expect. And if result with lt, if result is error, then this crashes the program. If the result is error, then the enum result, since result is a enum, if the type of that enum is, or variant of the enum is error, then this expect method crashes the program and prints the input string which we have given it. Okay, but if result is okay, then this returns the number of bytes read. But due to some reason, this is not like giving the exact bytes which were read. This is giving number of bytes plus one. I think it is also reading a new line character here. Shit, it is. I think it is reading new line character. Yeah, because when we write this, we press enter. So I think it is also reading the new line character. That would make sense. We can actually check if my intuition is correct. We can check this. If we do guess dot 0, if this is not a error. Yeah, wait, LSB is off. Let's say guess dot 0 and cargo run. Okay, unknown field. Okay, so we do not do this in Rust. Okay, there must be some other way to access characters from a string. Rust analyzer, and this is error. So how do we access things inside a string? There must be some way to access like characters from a string in Rust. Yes, I think C and C++ are balanced syntax wise, so not so hard like Java or Rust, and not so easy like Python. Yeah, Python is crazy easy. It is literally English, but I don't get what is happening under the hood in Python. Yeah, that is the like bad thing I don't like about Python. I do not know what is happening in Python. I don't even know how interpreters work. Yeah, that is one thing. Not so hard like Java, Rust. Yeah, C and C++ are pretty cool. Pretty cool. I don't have to get too deep knowledge to write it, but some knowledge. Yes, you have to know a lot of prerequisite before writing Rust. Rust cannot be your first language. It would be like crazy. No, it should not be your first language. C can be your first language. Python can be your first language, but not this. Not this. Not this. This is too much. A lot of stuff. Okay, so this result is a enum which can have two different values. Result is enum can have two possible variants. Okay, and these variants are error and okay. And this, since this is a type, result also has methods. I think these, not that I think, I like almost know, I could say that these methods can read what the current variant of the result is, that is, if it is error or if it is okay, and act accordingly. That makes sense. Okay. Values of the result type, like values of any type, have methods defined on them. Yes, values of any type have methods defined on them. An instance of result has an expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the the message that you passed as an argument to the expect. Yep. So if this thing returns a result that is error, shit, this is a result. This, not that this is returning a result, this is a result. Yes, RST is a result type, and this is a method on result type. And if the value of the result is error, this will crash the program and output on the screen this function. This function will be outputted on the string on the screen. But if this result type is okay, we will get the number of bytes which were read. That is nice, makes sense. And if the instance of result is an OK value, expect will take the return value that OK is holding and return just the value to you so you can use it. Expect will take the return value that OK is holding and return just the value to you so you can use it. In this case, that value is the number of bytes in the user input. Okay, shit, that makes so much sense since result is a general type. So generally speaking, not generally, always OK would mean whatever this result type is representing, that operation went OK, and this OK will have information associated to what was happening. And in this case, since we are reading a line, that information is just the number of bytes read by the readline function. That makes sense. But if you were like doing something else, like something else, maybe I don't know what else things we could do, maybe creating a mutex string or something, a thread or something. And if something else returns the result, there OK would hold on to some other information which is more relevant to the operation which gave us the result type. Okay. If you don't call expect, the program will compile, but you will get a warning. Okay, if you don't call expect, you will get a warning. You cannot just do guess 0 for the first character. Yo. It also have option thing in Rust, like the value you are accessing might exist or may not exist. Shit. Yes. Shit. Yes. This is not C. I cannot like access anything I want. Get 10,000 value from this error. Something like that. Or I just watched Harkirat video. Shit. Okay, he said that. This makes so much sense because if we can just do this, this just is the same problem, which is with C and C++. This makes sense. If you don't call expect, the program will compile, but you will get a warning. Why do we get a warning if we do not do this? Six and cargo run. Okay, we didn't get a warning. Main.rs. Okay, this is the warning that we were. Wait, this is okay. This is the version of our game, not version of the Rust language which you are using. Source main this thing result that must be used. Okay, shit. Because of this, we didn't got a warning. If we were to do cargo run, now we are getting a warning. Help. If this is intentional, prefix it with underscore like this. Okay, then this warning would go away. Okay, makes sense. Yeah, makes sense. Rust warns that you haven't used the result value returned from readline, indicating that the program hasn't handled a possible error. Okay, yes. The right way to suppress the warning is to actually write error handling code, but in our case, we just want to crash the program when a problem occurs, so we can use expect. Okay, because if the like if we got error value from the result type, then we can just crash the program. We don't want to like handle the error. We can crash. It is okay. Okay, you will learn about recovering from error in chapter 9. Printing values with print ln placeholders like this. Okay. Okay, before moving, I would like to go to the washroom and I will be right back in a minute. Yep. You. I am back and let's see what the placeholder in print ln does. Aside from the curly aside from the closing curly brackets, there is only one more line to discuss in the code so far. This line. This line prints the string that now contains the user information, user's input. This curly brace set of curly braces is a placeholder. Think of this as a little crab piers, pincers, shit, like literally rust crab pincers that hold a value in place. When printing the value of a variable, the variable name can go inside the curly brackets. When printing the result of evaluating an expression, the okay, when we want to print the result of evaluating an expression, makes sense. Place empty curly brackets in the format string, then follow the format string with a comma separated list of expressions to print in each empty bracket placeholder in the same order. Printing a variable and the result of an expression in one call to print ln would look like this. Okay, this makes sense. If we know what we want to print, then we just write this here, and if you want to evaluate the expression which you want to print inside this crab pincers crab pincers, then we can give it as a comma separated list, and this thing would be evaluated and put inside this thing and would be printed like this: x equals 5 and y plus 2 equals 10. Okay, testing the first part. You guessed 6. Okay, that much. Yeah, does run. We have checked it. Okay, at this point, the first part of the game is done. We are getting input from keyboard and then printing it. Okay, generating a secret number. Okay, now we will be using libraries. A crate in Rust library is called a crate. Cool. Okay. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. Okay, yes, we cannot just say secret number is 10 and the program would always check if the number is 10 or not. We will use a random number between 1 and 100, so the game isn't too difficult. Okay, Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. Okay, so Rust's standard library does not have a random function. There is a crate called rand, and we have to use that. Okay, okay. and crate is just a library, external library, which you can add to our project. Using a crate to get more functionality. Yes, using a crate to get more functionality makes sense because we do not have this functionality. We would have to use a crate. So we are using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we have been building is a binary crate, which is an executable. Yes, shit, our program, this thing, main.rs itself is a crate. The rand crate is a library crate which contains code that is intended to be used in other programs and cannot be executed on its own because it does not have a main function, I guess. Okay, that makes sense. So we need a external crate. Remember that a crate is a collection of Rust source files. The project we have been building is a binary crate, which is an executable. Okay, share. Okay, there is a library crate and a binary crate. Our crate, which we are making this thing main.rs or our project, which is named guessing game. This is a binary crate because we can just execute. It's executable. It's binary, but the rand create, which is here, we cannot execute it. It is intended to be used in some other program, and yeah, it is intended to be used in some other program and does not have a main function. Okay, cannot be executed on its own. Cargo's coordination of external crates is where cargo really shines. Okay, cargo is used. Shit. I think this is ship terminology. Cargo ship, right? This is ship terminology. Cargo ships are vessels designed to transport goods and commodities across seas and oceans. Carrying uh, crates. These things are crates. Okay, makes so much sense because we are learning Rust, which is like a crab, and crab are in sea, and in seas we have cargo ships which have crates. Okay, everything is making sense. Cargo's coordination of external crates is where external crates, because this is external, not in standard. External crates is where cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml. Toml has a full form. Toml is Tom's obvious minimal language. Tom's obvious minimal language, that is it. File to include the rand crates as a dependency. Okay, we have to modify this to add rand as a dependency. Open that file now and add the following line to the bottom beneath the dependencies section header. Okay, that cargo created for you. Be sure to modify to specify rand exactly as we have here with this version number, so the code examples in this tutorial or the code examples in this tutorial may not work. Okay, we are going to use the rand cargo crate, rand crate, with this specific version is 0.8.5. In cargo.toml, and here we will say rand equals 0.8.5. Makes sense? Yeah, makes sense. So now how do we like get the code for this thing? In the cargo.toml file, everything that follows the header is a part of the section that continues until another section starts. Yes, makes sense. Yes, makes sense. Dependencies. In dependencies, you tell cargo which externally creates your project depends on and which version of those crates you require. In the case we specify rand, and I think there must also be a way to get the latest version, because you do not always want to type in literally by hand the like the specific version of every crate that you're using, or program might become too big to do that. Which means any version that is at least this, but below this. Okay, okay. In the case we specify rand crate with the semantic version specifier. Okay, we are like literally putting in the version 0.8, 0.5. Okay, we don't have version 1 for the rand crate. Okay, cargo understands semantic versioning, sometimes called semver. Okay, semantic versioning is literally a thing. This thing, semantic versioning. Introduction. In the world of software management, there exists a dreaded place called dependency hell. The bigger your system grows and the more packages you integrate into your software, the more likely you are to find yourself one day in this pit of despair. Major, minor, and patch. Yes. Okay. Major version, minor version, patch. This is a major version, minor, patch. Okay. Cargo and this way of specifying version for a project is called semantic versioning. Okay, and we have Argo understands this semantic versioning. The specifier 0.8.5 is actually shorthand for this thing, which means any version that is at least 0.8.5 but below 0.9.0. Okay, so in this minor version, the minor version must be the same 8, but the patch can be anything. Not anything, at least 5. Patch has to be at least 5 or above. Cargo considers these versions to have public APIs compatible with version 0.8.5, and this specification ensures you will get the latest patch release that will still compile with the code in this chapter. Any version 9 or greater is not guaranteed to have the same API as what the following example uses. Okay. Okay, this paragraph. Let's read this again. Here we have Cargo considers these versions to have public APIs compatible with version 0.8.5, and this specification ensures you will get the latest patch release that will still compile with the code in this chapter. Okay, APIs compatible with version 0.8.5. Cargo considers these versions to have, what does it mean for versions to have public APIs compatible? Okay. Cargo considers these versions to have public APIs compatible. Cargo considers these versions to have public APIs. And I think by public APIs, they mean what is the API which we can use to access functions in this crate. And these APIs will be compatible with the APIs which are given with version 0.8.5. Okay, and this specification ensures you will get the latest patch release that will still compile with the code in this chapter, because the public APIs of the version that we are getting is same, because our minor version is same. But if we were to change or go to a higher minor version, then the public APIs might change. That is a bit bad. Okay, so new minor or major versions are not backwards compatible. Why would they like to change public APIs with every major or minor release? Is not guaranteed. Okay, it is not guaranteed. They might or might not change, but I guess they won't change because that would be bad engineering. Changing your public APIs with every major or minor version you have. Now, without changing any of the code, let's build the project. Yo, that is something we are not using. Okay. But before that, we have a lot of things. 14 packages, crates.io. Let's go there. Crates.io. Okay, here we have a lot of crates. That is like npm registry. And shit, this is billion. Shit, 182 billion things have been there. And there are 200,000 crates in stock. We have all of these crates, and the one that we are using is called rand. Let's see, this is the one, and shit, the latest version is 9. We can see everything about this crate. That is nice. That is nice. And this one peaked. Shit, wait, this is very cool. Look at this. The way that these things are becoming like big and small. These bubbles slowly becoming big and small, and the thing on the left is like always with the mouse. This is very cool. And this changed side. Look at this. Now it is on the left of the mouse, and now it is on the right. This is cool. This is cool. And this thing peaked at here at this point. Like, why was this the time when this book was released? Shit, this is crazy. Okay, a lot of people were using random library at this point. Wait, shit, no, no, no. Yeah, everything peaked. Everything peaked. Maybe a new version was released at that point. Yeah, something happened. Okay, that is nice. That is nice. 15 packages were added, and boom, all of these things. Okay, cool. You may see different version numbering, but okay, what version do we see? They added version this, even though 9 was available when this thing was written, and we have added version 8.5, 0.8.5. Okay, and then okay, you may see different version numbers, but they will all be compatible with the code thanks to semantic versioning. Semantic versioning. Okay, and different lines depending on the operating system, and the lines may be in a different order. Okay, does not matter. When we include an external dependency, cargo fetches the latest versions of everything that dependency needs from the registry. Okay, whenever we need a external dependency, cargo fetches the crate which we need from the registry, which is a copy of the data from crates.io. Crates.io is where people in Rust ecosystem post their open source Rust projects for others to use. Okay, okay, okay. Cargo, crates.io is where people post their things. Okay, and registry is a copy of the data. So crates.io is like this website, and registry is a copy of all of these datas of all of this data, and cargo fetches copies of crates from the registry and not from crates.io, it seems, which is a copy of data from crates.io. Okay, after updating the registry, cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, cargo also grabbed other crates that rand itself depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. Shit. Okay, this is crazy. Rust compiles the crates, the external crates. So Rust is downloading the source code for the things. And where is it? Wait, is it in the source? Nope. Nope. Where is the source code? Wait, did we like delete the source code and only kept? Okay, they are dependencies. Dependencies example. This is our like final binary. This is dot D, I guess debug information, incremental. Shit, this is the different things we have built or something like that. Then examples, nothing. Dependencies. Shit, these are all the dependencies. And we only have object files for these. Get random D. These two are object binaries, and our lib, our meta. Okay, a lot of these things are just empty, non-human readable. Okay, and source files. Okay, so create cargo downloads source code and compiles it with our own source code, and yeah, makes a binary for it. That is crazy. That is crazy. If okay, compiles the project with the dependencies available. If you immediately run cargo build again without making any change, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml. Okay, so it does not repeat the actions. That is fine. That's like okay. Then cargo also knows that you haven't changed anything about your source code, so it does not even recompile our own source code. That is also nice. With nothing to do, it simply exits. Let's see. We are getting error because we are not using RST. Let's actually use RST. So we came back. cd so main.rs and rst.expect unable to re-enter. And if we do cargo build, and if we do cargo build, yep, in the first case we did compile because there were changes in our main file, but in the second case we didn't recompile. That is nice. Cargo knows that it has already downloaded, and yeah, if you open the source main file, make a trivial change and then save it, and then it will recompile. Okay, these lines show that cargo only updates the build with your tiny change to this file. Your dependencies haven't changed, so cargo knows it can reuse what it has already downloaded and compiled for those. And when cargo downloaded the source code, it deleted the source code and only has the compiled binaries which cargo or like rust c compiled. That is okay. It is okay. And then cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. That is lock. Wait, shit. Cargo will use only the versions of the dependencies you specify until indicated otherwise. For example, say the next say that next week version 0.8.6 of rand crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.log file the first time you ran cargo build. So now we have this in the guessing game directory. Makes sense. Yep, cargo.lock. It knows the exact version we used for building our binary. So that is nice. When you build a project for the first time, Cargo figures out all the variations of the dependencies that fit the criteria and then write them to the cargo.log file. Cargo figures out all the versions of the dependencies that fit the criteria and then write them to cargo.log. When you build your project in the future, Cargo will use the cargo.log file exists. We'll see that the cargo.log file exists and will use the versions specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically, and you cannot just say it works on my machine. So, okay, that fixes the it works on my machine issue. In other words, your project will remain at 0.85, 0.815 until you explicitly upgrade thanks to cargo.log file, because the cargo.log file is important for reproducible builds. It is often checked into source code with the rest of the code in your project. So whenever you are sending a project to someone else, you also send the cargo.log file, I guess. And that makes sense. Okay. Cargo.log, so that you have a like a reliable build, the same build over time. That is nice. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo.log file and figure out the latest versions that fit your specifications in cargo.toml. The latest versions, but it will not go all the way and fetch 0.90 version. It will still adhere to the things which we have written in cargo.toml. Makes sense. Cargo will then write those versions to cargo.log. In this case, Cargo will only look for versions greater than 0.815 and less than 9.9. If the rand crate has released the new version 0.8.6 and zero point 0.9, you will see the following update. Okay, updated this to this. Okay, I think we can check this. Uh, okay. Let's cargo.log. Okay, we have a lot of things. I don't know how to change this, but let's rmrf cargo.log and go to cargo.toml, and let's say we want version 7, right? Minor version 7, and let's go to target debug, and we can just remove the target thing together. Yeah, the whole thing. And then cargo build. Okay, we have this version of rand 0.7. That is nice. And now if you were to do cargo update, nothing updates. Zero packages to the latest version compatible. Okay, and then if you were to do if you were to change what we have given here and say 8, we would get the version 0.8.5, because we will get any version that is at least that is specifically minor version 8, but the patch can be anything, the latest patch. So now if we do cargo update, bro, now it works, and rand got changed. Yep, that is nice. And we didn't go from minor version 8 to 9 because we specified we want 8 and the patch is latest. Okay, cool. That makes sense. That is pretty nice. Cargo ignores 0.9 release. At this point, you would also notice a change in your cargo.log file. Okay, nothing that the version of the rand crate you are now using is no shit. We are using 0.8.6. To use rand version 9 or any other version, we have to do this. Okay, you have to update cargo.toml file to look like this and then do cargo build or cargo update. Okay, there is a lot more to say about cargo and its ecosystem. We will discuss this more in chapter number 14. 14 is tomorrow, 14th of October. But for now, that is all you need to know. Cargo makes it very easy to reuse library. So rustaceans are able to write smaller projects that are assembled from a number of packages. Okay. Okay. Now on to how do we actually use this package. Let's start using rand to generate. Okay, and this thing comes in this library. Shit. Okay, we already have the standard library. Now we are saying from the standard library, we are using this module rng range, I guess. The next step is to update main.js as like this. Okay, we will be using the range module from the rand library and let secret number is rand threat range dot generate 1 dot dot equal to 100. That is cryptic and this number is not mutable. Like why would it be mutable? That makes sense. This doesn't make sense to be mutable. Okay, first we add the line use from the rand library rng module, which is the range module. Okay, the range trait defines methods that random number generators implement. Hmm. Trait. Range is a trait, whatever it means. First we add this line, okay, and then the range trait defines methods that random number generators implement. Okay, this thing defines a method that random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover this in more detail. Okay, okay. Okay, so a lot of things here are not going to be fully in detail, and that is fine. That is okay. That is okay. Next, we are adding two lines in the middle. Now, next, we are adding two lines in the middle. What are those two lines? The secret number is this. Please input your answer. This and this. These are the new two lines. In the first line, we call in the rand library this function, but we are skipping the module part. We are directly calling a function from a library that gives us, okay, I guess maybe because rand only has a single module, I guess, or maybe the rand library is defining everything in this namespace called rand rand. The function that gives us the particular random number generator we are going to use, one that is local to the current thread of execution and is seeded by the operating system. Then we call the generate range method on the random number generator. This method is defined by the range trait that we brought in scope with the use rand range statement. The get range method takes a range expression as an argument and generates a random number in the range. The kind of range expression, we are using here takes the form start dot dot equal to end and is inclusive on the lower bounds and upper bound. Okay, inclusive on both the bounds, and we need to specify this to request a number between 1 to 100. Okay, that is just a lot of information. That is just a lot of information. Yep, that is a lot of information. Let's see. Okay, we add two new lines in the middle of the code, this and this. And even before that, we are using this, which we will cover in more detail in chapter 10. Okay. Okay, so we can conclude for this part at least that this thing is bringing some functions in scope which are being used by other things. That is why we need this thing to be in scope. Okay, that is the conclusion we can draw for this, and move on to the next line. Next, we are adding two lines in the middle. In the first line, we call this function that gives us the particular random number generator. This gives us a random number generator we are going to use. Okay, one that is local to the current thread of execution and is seeded by the operating system. So a random number generator needs a seed which it uses to generate a random number, and this function returns a random number generator where the seed is seeded by the operating system, it seems. And yes, we just have to take a lot of things here with a grain of salt, not like unsatisfied, because we are aiming to build this whole thing in one stream, and also we like this thing is not comprehensive. Here they are just giving us an overview of how things work. So yeah, we don't have to delve completely deeply because there are the other chapters for that. So this is nice. This is all we will be doing. Okay. So this thing is returning a random number generator which is taking its seed from the operating system. That is what it seems like. That is local to the current thread of execution and is seeded by the operating system. Then we call the generate range method on that random number generator which we got. This method is defined by the range trait that we brought in scope with this. Okay, traits are something. There are also traits in C++, and they define what an object looks like. They define the feature of an object. And okay, so I think here in Rust, traits also mean that thing, but instead of defining things for a object, because we do not have objects in Rust, here traits define methods for types, and this thing thread range is returning a type, and this type does not inherently have a function called generate range, but when we include this trait into our scope, then this type has a function called generate range, and we can just call it. Okay, I think that is a nice guess of what might be happening here. Okay, this method is defined by the range trait, okay, because that is what the definition of traits is in C++. So I think this is a nice conclusion that we brought into scope with this statement. The generate range method takes a range as an expression, as an argument, takes a range expression, and this is how we give a range expression, an expression that evaluates to a range. Can we use this? Like, does this thing have a print definition? Like, main and does this thing println lsp start rust analyzer. We can do use rand and rng, and here println macro uh, range, and if we do 1 dot dot equal to 10, does this thing work? We cannot print a range. Inclusive integer doesn't implement format display. Okay, the trait this display is not implemented for range inclusive. Okay, in format strings you maybe, okay, they are now helping us. In format strings you may be able to use this thing or this thing for pretty print. Okay, and then rust c is telling us the same thing. Okay, just delete it then. So yeah, that is it. Range expression do not have a print method associated with them. Hello, good morning. How is everything going on? We are creating a game which is not a clickbait at all. First, we add the line using this. Okay. And okay, this is how we give the kind of range expression we are using here takes the form this. This is how we give a range expression. Okay, let's do this. Um, use in the random module range. Right. This thing is now in scope. And if we were to say let or mystery number equals in the rand module called the thread range function. Yeah, works on the current thread, and on that function call the generate range function, which takes in a range, and the range is going to be 1 to 100. Okay, makes sense. And then we will say println mystery number is this mystery number. And if we do cargo run, okay, mystery number is 30. Cool. They are printing in the wrong order, which is messed up. They are printing in the wrong order. No, they are not printing in the wrong order. That is like, no. Cargo run and enter your guess, and random number is now 90. Good. They are printing in the exact correct order. Random string. Yo. Of course, we are creating a game. Yes, we are creating a game. Yes, no kidding. This is an actual game where you have to guess a number between 1 to 100. Yeah, actual game. You are like applying binary search on this range. And note, you won't just know which traits to use and which methods and functions to call from a crate. So each crate has its own docs. Shit. Has documentation with instructions for using it. Another neat feature of Cargo is that running the cargo doc dash dash open or tac open command will build documentation provided by all your dependencies locally and open it in your browser. If you are interested in other functionality in the rand crate, for example, you use this and click rand in the sidebar on the left. Shit. Okay, okay, let's do this. Cargo, doc, doc or docs, doc, open. And okay, it is building documentation for the random library. That is crazy. And allow. And this is like locally available. Look at this index.html. And if I click on the random library, everything is here. Shit, that is too good. It even has links to different things. Shit, function, range, thread function, retrieve the lazily initialized thread, local random number generator. Shit, that is too good. Rest documentation is too good. High, low type game. Yeah, this is a high, low, high game. Yeah, yes. High, low. Cold or hot kind of game. You are like closer to the correct answer or not. And we have been like halfway through, which is like pretty cool. I have not been yapping a lot, so that is cool. We have made a progress. But yeah, okay, and we have built our own little documentation here in the main.rs file. This is the hierarchy. We have libraries, libraries have modules, modules have functions. And there is a special type called the return type, which is a enum. And this enum has two possibilities. And those possibilities that a enum can have. These are called variants. So this enum has two variants, error or okay. Hmm? Error or okay. And yeah, this enum also has methods because this is a type. Types can act as namespaces we saw yesterday. And yeah, namespaces have methods. So this also has a method. And this result type, we have this result type has a associated function called expect. And this expect function can see what the variant of this type is. And depending on that variant, if result is error, then this expect function crashes the current program and prints the input string. Like here, when we are calling this expect function on this result type, if we get error, then the program will crash and we will see this string on the standard input. Or if you were to be like pedantic, first you will see this string printed on the output input, and then the program will crash, because if the program ends, who is printing the string? So first we have to print the string and then the program stops. But if the result is okay, then this thing returns the number of bytes that were read, which you can actually like store and print ln bytes read bytes. And I think this is also like, along with what we have printed, this is also reading the new line. So yeah, this like gives a higher number of byte than we are inputting. Cargo build. Okay, cargo run. If I say hi, this is 2 bytes, and then I press enter. This is the standard input library read 3 bytes, and I guess it is because it also read the new line character. And that is the reason we are getting here 2 new lines. One new line here, one new line, just println just adds one new line by default. And the second new line is the thing which comes with our guess. So if I were to say first new line here, then my suspicion is we will print hi, then a new line, and the thing which says first new line will be printed on this line, and yeah, then a new line. Hi, yo, let's go. First new line. That is how it works. That is how it works. Hello. First, try brute forcing, then optimize. Oh, yes, yes, we can use that. Hello. It read enter as input. Yes, that is why it is saying like 3 bytes. That is crazy. Yes. Yes. Okay, we can brute force. We can brute force, and with a like higher range, like 10,000 or something, we can also brute force there. Like, what better thing do we have than doing this? First, we add. Okay, okay, okay. This is done. This is done. The second new line prints the secret number. This is useful while we are developing the program. Okay, but we will remove this line for our release version of the game. We will not have this print secret number line in our release version because that is not good. This is useful while we are developing the program to be able to test it, but we will delete it from the final version. It is not much of a game if the program prints the answer too soon as it starts. Yeah, they are using a lot of exclamation marks. That is crazy. Try running the program a few times, and yes, we will get different numbers. We did get different numbers. Here it was 91, 87, and something else above. Now comparing the guess to the secret number. Shit. Shit. Can I send it on the chat? Any skillet learn tutorial recommended? I need to learn basics of it for schoolwork. Yes, release version. Release version is also one thing. No, I don't know how to, like what this thing even is. I think it is a machine learning library. Skillet learn. I don't know about this. Skeleton, Python, sklearn is a free and open source machine learning. Okay, it is machine learning. Shit, I did see this. I was watching a like machine learning video online. And you can just read the documentation. Go there, quick start or user guide, tutorial. There you go, tutorial. Supervised learning, generalized linear models. Read this. Look at this. Read the maths. Shit. Vector, y hat. Look at this. Read this. You can go through the tutorial. This is just the first chapter. Not even the first chapter. This first part in the first chapter. Shit. This is the whole tutorial. This whole thing. Shit. That is too big. No, shit. This is the whole thing. 1.1.16. 1.1.16. Okay, so this whole page is the only thing you have to go through. That this is good enough. Wait, that was not the tutorial. This is the tutorial. An introduction to machine learning with SCI kit, science kit, shit, science kit, SCI kit, science kit. Yeah, you can do some of these things. And we have our local documentation of Rust, which is amazing. And good luck with the library. Yo, good luck with the library. We are now using another function, standard library function. Now that we have our user input and a random number. Yes, we have user input, we have random number. We can compare them. That step is shown in listing 2.4 in this thing. Note that this code won't compile just yet, as we will explain. Okay, so there is something wrong with this. And shit, the crab is wondering what is wrong. We import this. Not we are importing, we are bringing this ordering function into into our current scope. Okay, main snip is, I guess, this thing, the things we wrote above, and print ln, your guess, match, and this is our argument for match, and this is how we are handling if this thing equals ordering less than this, if this thing equals ordering this, and this. Okay, so what is the problem with this? First, we have to add another use statement bringing a type called CMP ordering into scope from the standard library. Okay, the ordering type is another enum and has the variants less, greater, and equal. These are the three outcomes that are possible when you compare two values. When we compare two values and compare, okay, I guess compare is not in the scope, but compare comes with guess. We are comparing guess with this thing, and should we are passing this number as a reference. Should we are even passing a number as a reference? That is messed up, kind of. We are passing a number as a reference. Scikit. Makes sense. Scikit, science kit. We are passing a number as a reference. We do not want to copy a number. Shit, Rust is too much. Too much in the sense it is too good, not in the bad sense. Rust is good. Okay. Uh, so we are first adding this thing to bring ordering into the scope. Then we go full page. Then we add 5 new lines at the bottom that use the ordering type. The compare method compares two values and can be called on anything that can be compared. Okay, anything that can be compared. I think this will make more sense when we read more chapters, more depth chapters, more deep chapters like Nietzsche. It takes a reference to whatever you want to compare with. Okay, it is comparing guess to secret number. Then it returns a variant of the ordering enum of the ordering enum. Okay, we brought into scope with use statement. We use a match expression, which is like switch, to decide what to do when based on which variant of ordering was returned from the call to compare with the values guess and this. Okay, this match statement is using this as the argument, and depending on what is returned by this, either this or this, we do this or this. Okay, a match expression is made up of arms. These things are called arms. These different conditions in the switch or match are called, wait, is it a reference to a rust thing like a crab having the multiple arms? Match arms. A match expression is made up of arms. An arm consists of a pattern to match against and the code that should be run if the value given to match fits the arms pattern. Okay, Rust takes the value given to match, yes, and looks through each arm's pattern and turn patterns and the match construct. Patterns and the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. Yes, okay. As we were seeing yesterday, we have to handle everything that is there. Now, let me give you a brute force approach. Okay, that's fine. You said to me, or I am just messing up, or combining two things. Ask to generate random number, use loops, won't tell you how, and okay, and also if guess is greater than random number, written high else low, and on guess equals get out of the loop. Yes, we can use a loop. Yeah, I mean, I guess they will just put this inside a loop because this is just shit one-off match. We have a 1 in 100 chance getting this right. We will, I guess, put this into a loop later at some point. Let's see, let's see. Yeah, arms, match has arms, okay. We will walk through an example with match expression used here. Say that the user has guessed 50 and random number generated is 38. When the code compares 50 to 38, the compare method will return greater. Yeah, it 38 is the secret number and we are passing in. Okay, so it is saying the guess is greater than the secret number. Okay, guess is greater than the secret number. The value and starts checking each arm's patterns. It looks at the first arm's pattern less and sees that the value greater does not match less. So it ignores the code in that arm and moves on to the next arm. The next arm's pattern is greater, which does match, and the associated code in that arm will execute and print too big to the screen. The match expression ends after the first successful match, so it won't look at the last arm in this scenario. However, the code in listing 2.4 won't compile. Let's try it. Okay, there is some expected string. Shit. Okay, I saved 1 hour of yours. Shit. Thank you for that. I would be debugging this with LLDB for like 1 hour. Thank you for that. And shit, I have to go to the washroom. I'll be right back in a minute. Yo, I am totally back. Let's do this. Shit. Yep. Okay, so if we compile, this is not going to compile. Wait, we haven't even made the updates. Main.rs. We have to use std cmp, and the thing was ordering. Let's start rust and laser compare ordering. Yeah, good. And we are not using this, so we are getting some errors. Let's delete this whole thing. Okay, first what we will say, we will say print ln uh, number guessing game, and then yeah, we have to say, yeah, enter number, and then we will read the number for which we need a string. Let mutable guess equals string new. We are getting a new string type, and we also need a secret number for which we'll say let secret, or just secret. Secret is good enough. Let secret equals a random number, thread generate dot range, generate on a range, and the range is dot dot equal from 1 to 100. So we do have a secret number. Okay, let's read the thing. IO stdin. Stdin will return a type of standard input, and on that thing we are calling the method read line and a string. Enter your guess and then expect. Unable to read uh, guess for like error handling. Okay, read line is giving us some error. Okay, which makes sense. Which makes sense. Shit, how can I even do this? A reference, a mutable reference to guess. Okay, whatever you read, the read line function, whatever you read, put it inside this mutable string called guess. Okay, and we are passing it as a reference. Then we want to compare the secret number with this number. So match guess dot compare with secret. This is error. And wait, what is the syntax for match? I guess, yeah, we use curly braces. And here we have ordering. If less, why is this in like capital letters? If less, then print ln. Uh, if less, if less, yeah, guess is less. Too low, comma. I think I can stop the LSP. LSP stop. Ordering. If should I do need the LSP. I do need the LSP. LSP start. That is not the correct spelling. Trust analyzer. Greater, and if greater than print ln too high, and otherwise ordering. Where are the auto suggestions? LSP restart. Equal. Okay, that is good. Print line. Bingo. LSP stop. Yeah. That was okay. Okay. But if we were to compile this, you will get error because guess is a string and secret number is a number. We cannot compare a string with a number. The core of the error states that there is a mismatched types. There are mismatched types. Rust has a strong static type system. However, okay, strong static type. Static type means at the compile time, type of every variable is known, right? That is static type. And strong, I guess, means types. No, shit. Static means types are fixed. Types do not change. What does strong mean? Uh, shit. I will have to look it up. What is strongly typed language? It strictly enforces data types for variables, preventing operations on incompatible types and requiring explicit type conversions. So strongly type means you cannot just do anything on anything. Certain types can only do certain things. A statically typed language has a type system. Static versus dynamic, strong versus weak. Shit. Lua mentioned. Lua. The opposite of statically typed is dynamically typed, which means values used at runtime are classified into types. These are restrictions on how such values There are restrictions on how such values can be used. When those restrictions are violated, the violation is reported as a dynamic type error. Okay, let's not read this. I would say that static type means types of things are known, types of variables are known at compile time, but dynamic and yes, they are known at compile time and they are fixed. And dynamic means they are known with shit, they are mostly in like interpreted languages, but the thing is types can change. A variable can change its type, like in Python or like in Python. Maybe in JavaScript, shit, I do not remember. In JavaScript, if we can, it is if we can change types of things. I think we can. I think we can change types of things in the JavaScript also. And then strong and weak. Weak would mean you can do anything with anything. Like in Python, you can add a number to a string, crazy, but strongly typed, you cannot do that. You cannot do that. The core of the error, mismatch. Rust is a strong static type system, has a strong static type system. However, it also has type inference. When we wrote this thing equals this, Rust was able to infer that guess should be a string and didn't make us write the type, which we can like manually write if you want. Shit, no. Secret is a wait, I don't know. Secret is a number, but guess is a string. And does it also give us any help? No, nope. Okay, but with that, and it didn't make us write the type. Okay, it was able to infer. The compiler was able to infer the type of a string. For the the secret number, on the other hand, is a number type I32. Shit, yes, I32. We can write here I32. I32. We don't have to because of inference, but of course, okay, let's write. Well, U32 is an unsigned 32-bit integer. I64, 64-bit number, as well as others. Otherwise, unless otherwise specified, Rust defaults to I32, which is the type of secret number, unless you add more information. Unless you add information elsewhere, that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number. Type makes sense. Ultimately, we want to convert the string the program reads as input into a number type. So we can compare it numerically to the secret number. We do this by adding this line to the main function. Read, okay, and then let guess U32. So we are like changing the thing, shadowing. This is called shadowing. We saw yesterday, and we do guess trim, remove spaces from the left and right, and parse. I guess we'll just parse this thing according to this type. Unsigned 32-bit number. and this thing returns a result, and on that result we are calling expect. Okay. Okay, we can do this. After reading, let guess, now it is no longer mutable. Guess equals guess dot trim, which returns the trimmed version of the string, and then parse on this we are calling the expect, uh, unable to parse, and we are saying that this guess is of I32 type, and also your guess is some number. Okay, let's see if we can get this right. If this even compiles, that is okay. Doesn't compile. Okay, we have to send the thing as a reference. This has to be a reference. Okay, cargo run. Okay, shit, I messed up. I messed up. Cargo run. Is 5 the number? 5 is too low. Is 50 the number? That is still too low. Is 5 the number? 5 is now too high. Okay, I entered 55. If we do this like 100 times, we are guaranteed on like the probability is we will get this right once. Okay, yeah, we will get this right once at least if we do this for like 100 times. Okay, this thing converts the guess from a string into a unsigned 32-bit integer. Or we can add a loop. Let's see. I don't know how to write a loop in Rust, but let's see. Okay, but shit, in loop we would have to reread the thing, reread input. Okay, while Rust analyzer, while, okay, while true, infinite donations, and okay, we can take this, paste this here, and in here we do bingo, and okay, check. How do we break? Let's just say, is break a keyword? Yes, break is a wait, when you do use break here, do you break out of the match or break out of this or this? Print ln bingo. Nice. And then break, or can we exit the program itself? Yes, we can. Yes, we can. Exit with the exit code 0. std exit. Okay. Standard. Okay, cool. Chat. Exit code is 0. This is okay. Yes, this is okay. This is okay. Okay, our game is ready. Our game is ready. Or we could, yeah, this is fine. This is fine. Wild fruit is fine. Cargo run and guess a number. Let's do binary search 50. Hmm. Hmm. Unable to parse. Okay, this makes sense. This makes sense because yeah, the type of guess changed. We have to do this like every time that we are here. Or no, we yes, we do have to do this every time because we want to read the new thing. Yeah, completely. Cargo run 50. 50 is too low. 75. 75 is also too low. 87. 87 is also too low. Shit. 90. 93. 93 is too low. Shit. 97. 97 is too high. So answer is between answer is 94, 95, 96, 95. Bingo. Shit. That is a nice game if you want to play. Hello, how is everything going? We have just built a game in Rust. Look at this. Clear, cargo, run. Ignore the errors. This is fine. Enter a number. All right. We have to enter a number between 1 to 100. Let's say 50. 50 is too low. Let's go 75. 76. 76 is also too low. 87 again. 87 is now high. Let's go to 70. 70 is low. 75. 75 is low. So 80. Shit. I messed up my binary search. 80 is too low. 84, let's say. 84 is too high. So answer is between 81, 82, 83. Yeah, and these three numbers, 81, 82, 83. Three numbers. 82. Bingo. Shit. Yeah. Yeah, we are too good at this. Uh, for a few days. For a few days, I guess I will be starting competitive programming again tomorrow. That would be nice. And yes, today we will just finish and ship this game. Right? Today we will ship this game in Rust. We can do the build release, cargo, build release, build this for the release. And we do have the build for release. And this did take time, even though this was a like very simple program. That is crazy. Hello, what is CSHB in your bookmark? Competitive Programming Handbook. Yep. Competitive Programmer's Handbook. Yo, bro is stalker. Bro is seeing everything. Okay. Yep, now we have this thing working. That is nice. We create a variable. So yeah, this line is converting this string into a integer, unsigned 32-bit integer. Okay, that is nice. We create a variable named guess, but wait, doesn't the program already have a variable named guess? Yes, it does. It does. But helpfully, Rust allows us to shadow. Shadow is a general term. Shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess. For example, we will cover this in more detail in chapter 3. That would be nice. Okay. But for now, know that this feature is often used when you want to convert a value from one type to another type. That makes sense. That does make sense. We bind this new variable to the expression guess.trim.parse. We bind this new guess variable of type 32, unsigned 32-bit integer, to this thing. What is returned by this? Okay, shit. Now we are seeing the thing which you saw above. Okay. This thing, this part, this is a string, right? Guess is a string. On this string, we are calling the trim method. And this whole expression returns a new string. and on that new string we are calling the parse method, and this whole thing is returning a type called return type, which we saw above. Where is the return type? Your guess. Share. It was even before this. Yep. Here. Result, not a return type. Result. So that thing is returning a type called a like instance of a type called result. That result is a enum which can have error or okay, and if it is error, if what is returned by this thing, the result type, if it has the value error, then this function will stop the current program. Yeah, this function will stop the current program and output this string. If the type of that result is okay, then this function will return the information which is in that okay type, and the information here would be what the integer representation of that number is. So this whole thing will return, if okay, the integer representation, or otherwise will exit, will crash the program and print this onto the terminal. That is nice. Makes sense. No, I couldn't ignore anything that starts with CS. Bro, bro has like a pattern recognition in his brain fixed in the at the hardware level. Okay. Then this new guess variable is being binded to the value that is being returned by this. We bind this new variable to the expression this. The guess in the expression refers to the original one. This one refers to the original one, and this is our new one that contained the input and the string. The trim method on a string instance will eliminate any spaces at the beginning and end, which we must do, before we can convert the string to a U32, which can only contain numerical data. The user must press enter to satisfy read line. Read line, okay. To satisfy read line stops reading line when we press enter. And input there is, which adds a new line character to the string. That makes sense. That makes sense. That is why when we were seeing how many bytes were read into a string, it was 3 instead of 2 when we were inputting high, because it was also reading the new line at the end of high. So 3 bits, hi, and new line, 3 bytes. And input their guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, the guess looks like this, 5 and the new line. So therefore we have to use trim to get rid of this new line. Okay, the new line represents new line. Okay, and on Windows this is a carriage return. Carriage return is this \r and then new line. The trim method eliminates both of these and just returns 5 as a string. The parse method on a string converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess 32. So we have to explicitly tell guess is a 32-bit integer, 32-bit unsigned integer, and here the compiler won't be able to infer from this thing on the right that guess is supposed to be a unsigned 32-bit integer, so we have to explicitly say unsigned 32-bit integer. The colon after guess tells Rust we will annotate the variable's type. Rust has a few built-in number types. Unsigned 32-bit seen here is an unsigned 32-bit integer. It is a good default choice for a small positive number. You will learn about other things in chapter 3. Yeah, chapter 3 I guess is going to be pretty nice then. Additionally, the U32 annotation in this example program and the comparison with secret number means Rust will infer that secret number should be a unsigned 32-bit as well. So now the comparison will be between two values of the same type. Okay, okay, okay. So both the values will be of the same type. Unsigned 32-bit integer, guess is unsigned 32-bit integer, but the random number, secret number is not. Secret number is, what is the type of secret number? Okay, I guess it is just I32, 32-bit integer, unsigned integer. Okay, the parse method will only work on characters that can logically be converted into numbers. So can easily cause errors. Yeah, so this can easily cause errors. If, for example, the string contained like this, what the hell is this? There would be no way to convert that to a number because it might fail. The parse method returns a result type yes, much as the readline method does, discussed earlier in handling potential failures with the result. Yes, parse returns a result type on which we call the expect method. We'll treat this result the same way we by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect will crash the program and print the message we gave it. If parse can successfully convert the string to a number, it will return the OK variant of result, and expect will return the number that we want from the OK value. Makes so much sense. Too big. Now the program is working, but this is one off. Allowing, now we'll use loop. Shit, loop is literally a keyword there. Should loop this. That is crazy. Just loop, use the word loop. We have most of the game working now, but the user can only make one guess. Let's change that by adding a loop. By the loop keyword creates an infinite loop. We will add a loop to give users more chances at guessing the number. Okay. Loop, cargo, run, right? Yep. Number 50. 50 is too high. 25. 25 is also too high. Let's say 17 or 13. 13 is also too high. 7. Bingo. Yo. 4 tries just said. I just saved you. Yes, bro did save 1 hour. Here we have loop. Like literally, we have loop. Loop as a keyword. That is crazy. That is like literally crazy. This is for infinite loop. Loop. And to exit, I am using this thing. Like literally the exit function. Exit 0 to exit from the program. Let's see what they are doing here. Put all of this in a loop. Okay, then as you can see, we have moved everything from the guess input prompt onwards. Secret number inside the loop. Please input number. And then yeah, we have everything here. Please input number, and the creating a new string also is in here. Makes sense. And then into a loop, be sure to indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask for another guess forever, which actually introduces a new problem. It doesn't seem the user can quit. Yes, even after winning, you win. Please enter and quit. What is quit? Okay. The user could always interrupt the program by using the keyboard shortcut Control C, but there is another way to escape this insatiable monster, as mentioned in the parse discussion. In comparing the guess number to secret number, if the user enters a non-number answer, the program will crash. We can take advantage of that to allow the user to quit, as shown here. Quit. Shit, this makes sense. This makes sense. If we do not enter a number, it will quit. Shit. Let's say 50 binary search. 25 is too low. Okay, we have to go up. 37. 37 is too high. What is between 25 and 37? 30. Bingo. Well, our program is exiting because we are clever. Let's stop the line. Cargo. Run. 50. 50 too high. 25. 25 too low. 37. 37 is too high. We go 30. 30 is too low. Okay. 34. 34 is too high. 30. 32. 32 is too high. 31. Bingo. And enter a number. Quit. Exit, because quit cannot be converted into a number. That is true. No, no, this would not work. Strongly typed. This is strongly typed. So I think, I don't know specifically, but I think we can here only have the statements which this value can take, since this thing returns enum called ordering, which only has three like variants. So these three variants are the only things we can use here and nothing else. But still, let's say if we get okay, I don't even know how to compare with a string. Maybe just use this quit. If quit, or like if we do use break here, let's see, will this break out of the match statement or out of the loop statement? That is a good question. Cargo. Too high, shit. Too low, 37. Too low, okay, 45. 45. Yes, 40, 43. 43 is too high. Then 41 or 40. 40 is too low. Okay, 42. Bingo. And we do break. Okay, that makes sense. But if you were to see the laptop dying and break, I think this won't work. Because like, yeah, ordering is a enum which cannot have the value quit, so we are checking for something which this thing will never be equal to. Shit. Just a minute. Yep, because this thing will never return a type called quit. LSP start rust analyzer save, and there is error, mistake, problem. Yeah, this expression has a type. Use stdio. Yeah, this is not good. This is fine. Cool. Okay. Yep. If match is broken, loop gets terminated automatically. Yes, that is how it works in most languages. Yep. Okay, that is how it works in most languages. That is good. Typing quit will quit the game, but as you will notice, so will entering any non-number input. This is suboptimal to say the least. We want the game to also stop when the correct number is guessed. Quitting after a correct answer. Let's program the game to quit when the user has won. When the user wins by adding a break statement here. Yes, this is exactly what we did. Adding the break line after you win makes the program exit loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program because the loop is the last part of the program. Exit, yes, exiting the program because the loop which you used is the last part of the program. Handling invalid inputs, and that is the last part. Shit, we have a releasable, shippable game right here. Look at this. Cargo, build, release, build. Okay, the spelling is wrong. Here, cargo, build, release, release. We have the released version. And target, release, right here, dot slash, guess in game, 50. Ah, shit. That is what? 25. Well, actually, this game is a bit fun. This is low. Okay, 43. Low, 47. Too high. So 44 or 45 or 46. Let's say 45. And I think that is the answer. Shit, that is too low. Okay, 46 is the answer. 46 is the answer. Bingo. It's first try. That is how it works. First try. To further refine the game's behavior rather than crashing the game when the user inputs a. Wait, we are not crashing the game. When the user. Okay, for invalid input, non-number, let's make the game ignore a non-number so the user can continue guessing. We can do that by altering the line where guess is converted to a string from a to a 32-bit. Here, parse, and then we are doing this. If okay, shit. Okay, we are calling match because match is also an expression. Shit, this makes so much sense. Match, everything is an expression. So match is an expression taking in this thing, and if this thing is okay, num. Shit, okay, num. Ah, shit. Okay, this makes sense. This makes sense. Here we are saying if the type is okay, and in that okay type, we are unbinding a tuple. Unbinding a tuple. Yes, I think it is a tuple of, and we are putting that whatever the tuple contains that value into this variable binding called num, and then we are returning it. Otherwise, if error, then we are not taking anything. We are just like throwing it into the garbage and calling continue the whole statement. Okay, makes sense. Okay, we have a new version already for our game. Should go to programming, Rust, guessing game, and source. Yep. Okay. Right here, we are going to put this into a match statement. Match guess dot prim dot parse, and here if okay num, return num. Otherwise, if error, whatever it is, we are not taking it. Continue. That makes sense. Cargo run. Okay, at the end, we have to add that. Okay, here. Okay, cargo run and compiling and running. 50. If we say something else, some crazy number. Nope, it is asking us for number. 50 was too low. Let's say 75. 75 is also low. 87. It's 87 is also low. 93 is too high. 90. 90 is too high. So 88, 89, 89, 89. Bingo. Cool. This is now working. Okay, this is cool. This is cool. This is an expression where this is the like input type and we are matching this. These are different arms. Yep. Okay. We switch from an expect call to a match expression to move from crashing on an error to handling the error. Remember that parse returns a result type and a result is an enum that has variants okay and error. We are using a match expression here as we did with the ordering result of the CMP method. Ordering result with the CMP method. Yes, ordering result with the when we are like comparing less, greater, or equal, or whatever. If parse is unable to successfully return the string into a number, it will return. If it is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. That OK value will match the first arms pattern, and the match expression will just return the num value that parse produced and put inside the OK value. That number will end up right where we want it in the new guess variable we are creating. Yes, makes sense, makes sense. This arm returns the number which OK has and puts that number, and this same number would be returned by this match statement and will go to guess. Okay. If parse is not able to turn the string into a number, it will return error value that contains more information about the error. The error value does not match OK number pattern in the first match arm, but it does match the second arm. The underscore is catch all value. In this example, we are saying we want to match all error values no matter what information they have inside them. So the program will execute the second arm's code continue, which tells the program to go to the next iteration of the loop, like literal loop which we have. The loop. Okay, and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Exclamation mark. Now everything in the program should work as expected. Let's try. Yes, it is working. And this is the whole thing. This is literally the whole thing. We will rewrite the whole thing again once more. Awesome. With one tiny final tweak, we will finish the guessing game. Recall that the program is still printing the secret number. Okay, okay, just remove that line. Remove the printing secret number line. At this point, you have successfully built the guessing game. Congratulations. Thank you. Summary: this project was a hands-on way to introduce you to many new Rust concepts, let match functions, the use of external crates, and more. Yes. In the next few chapters, you will learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership. Ownership. a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and chapter 6 explains how enums work. Okay. Now with that, now with like everything working, what do we do? Language. Yeah, our program is working and that is pretty nice. It has been 3 hours and this works. That is nice. Is there anything else we can do? I guess not. We have built the whole game from start to end. That is nice. And we have seen a lot of new things in this. Guessing game, ls and source. Guessing game. Go to source main.rs. We have successfully written a program in Rust. That is nice. And that would also be the end of today's stream. So yep, we did what we set out to do, and that is nice. Yep, it took us 3 hours, and that is okay, pretty cool. And with that, that is the end of today's stream. And thank you for being here. Bye.